Today we're going to be talking about infinite limits. And when we talk about infinite limits, there's really two types of limits that we're talking about. So let me go through an example here with you, and then I will explain what I mean by that. So limit as x gets really, really big. So as x gets really, really big on our graph, it looks like we are going to -4. And x gets really, really small, again, -4. As we approach 3, so +3 from numbers a little bit less, we go up to positive infinity. As we approach 3 from numbers a little bit more, we go to negative infinity. So therefore, our limit here does not exist. So when you're looking at when x goes to positive or negative infinity, what you're looking for is a horizontal asymptote. And when you're looking at left and right sided, this is going to be a vertical asymptote. Okay, so different types of asymptotes when we're talking about infinite limits. So horizontal asymptote is as a line is a horizontal asymptote, I should say, if your limit approaches the same value from the left and the right. Okay, so for this example, remember what you remember from Algebra 2 and from pre-calculus. Okay, and you're welcome to graph it or welcome to give you tables, but the powers are the same on the top and bottom. Therefore, a horizontal asymptote is the ratio of the leading coefficients. So my end behavior, or my limit, I should say, which is really what a horizontal asymptote is end behavior. So my limit as x gets really, really big in this example is 1. X gets really, really small is also 1, and you can confirm that with a graph if you want. Identify horizontal asymptotes, y equals 1, because we approach the same thing from the left and the right. Now finding a model for the end behavior, which is really what happens, really what we're looking for is a limit as x gets really, really big of our function, and the limit as x gets really, really small of our function. So end behavior is the same thing as these limits. So what you want to look at is highest power on the top, the term with the highest power on the top, term with the highest power on the bottom, and all of these other terms don't really mean anything. So really what we're looking at is 2x to the fourth over a negative x to the third. Simplify that, and that simplifies to a negative 2x. So the end behavior, or the limit, would be as this gets really, really big, what's happening? As x gets really, really small, that's happening. In this case, personally, I would say there's no horizontal asymptote, because the end behavior, this is some sort of line. Okay. Now here, on our second example, again, cross off, just look at those highest terms, and reduce, and we get 7/3. Now, if we were graphing this, we would know that our horizontal asymptote is also 7/3. And the limit as x gets really, really big would be 7/3. Limit as x gets really, really small would also be 7/3. Okay, this example. Finding the limit as you get really big and you get really small. So using limit laws to justify my answer. So what I'm going to do is I'm going to look at this first one. And the second one, the second function, because I can break limits off by multiplication. And then here I can do limit as x goes to infinity of 4 over x plus the limit as x goes to infinity of 6. I'm going to find that. I'm going to multiply that to, let's talk about simplifying that. I can put that 4x squared over each one of the terms in the numerator, and that gets simplified to 7/4 minus 1 over 4x squared. So then I'm going to do the same thing I did with that other function. This is the simplified version, so I'm going to do the limit as x goes to infinity of 7/4 minus the limit as x goes to infinity of 1 over 4x squared, and then I'm going to find each one of these individual limits. Okay, so as x goes to infinity of this function is 0 plus 6 times by 7/4 minus, now as x goes to infinity of 1 over 4x squared would also be 0. So I would have 6 times 7/4, which is 21 halves. And this is what that horizontal asymptote would be. So if you graph this crazy function, if you graph f of x in your calculator, you're going to get 21 halves as your horizontal asymptote. Now with this step, I'm just going to look at the infinite limits, the negative infinite limits, I should say. And there's a lot of writing. I'm trying to think of a funny joke I could tell you guys. I really have no funny jokes. I do have a funny comic involving infinite limits. Remind me to show that to you guys in class. Okay, now we're done writing. Negative infinity. This function is still going to 0. This function still goes to 6. This function still goes to 7/4. This function still goes to 0. So our result is the same thing. Okay, what I want you guys to do right now is use the table of values to find each one of these limits. So pause the video and fill in this chart. For some of these, you're going to get something like you're going to get like something, I'm making up a number here, 397 times, and your calculator is going to say e negative 7. Remember, that means 3.97 times 10 to the negative 7th. So we can say in general that that equals 0. So right now, again, pause the video, find each one of these limits using the table of values, and I'm going to be looking for these tables of values in your notes. Okay, hopefully you filled in those tables of values. Again, I'm going to be looking for those in your notes. Hopefully you realize that both of these limits go to 0. So looking at an example with this, okay, so finding this limit and using limit laws to justify, so limit as x goes to infinity. Try and manipulate this into sine of x over x. So take your numerator and split it up into two terms, both of them being over the denominator. These x's can cancel. So my limit as x goes to infinity of 2 is 2 plus 0, so this value is 2. You can do the same thing over here. And this is a little negative infinity. I forgot my negative infinity. Okay, again, the x's cancel. This limit is also 2. This limit is also 0. I know we just did the positive versions on the last slide, but that limit is also 2. Or I'm sorry, is also 0. So that limit is also 2. So this function, the horizontal asymptote, would be 2. Okay, vertical asymptotes. So what you want to look at here is you have a vertical asymptote to the left, and to the right. So left and right, your limits are going to be either positive or negative infinity, depending on what happens with your graph. So first we want to do here when we're finding the vertical asymptotes, remember you want to factor the bottom. So when I factor my denominator, we get this. So you get negative 3/2 and 4. So really what we're going to be finding here is we're going to be finding the limit as x goes to negative 3/2 from numbers a little bit less of our function, and the limit as x goes to negative 3/2 from numbers a little bit more of our function. And then we're also going to be finding the limit as x goes to 4 from numbers a little bit less, and the limit as x goes to 4 from numbers a little bit more. And in general, I think we can handle doing these without a calculator. So let's do with the 4 first. So if I plugged in 3.999, so remember, this is the factored version of our denominator. So if I plugged in 3.9999999, I would have a positive on the top, and then I would have a positive term times by a negative term. So that's going to be some negative number, so that's going to be going to negative infinity. When I plug in something greater than 4, so like 4.00001, and I'm doing all this math in my head, okay, I know that that's really close, so I know to 4, so I know my numerator is going to be positive. This term is going to be positive, but this one would also be positive, so I'd be going to positive infinity. Now when I have a negative, okay, and numbers a little bit less, okay, you could choose something like negative 2 if you wanted. Okay, because whether I choose negative 2 or something really close to this, I'm going to have the same value. If I choose a negative 2, my numerator is going to be a negative number. This term in my denominator is going to be negative. And then I'm also going to have another negative, which is going to result in a negative number. So this is going to negative infinity. And then when I plug in something a little bit greater than negative 1.5, we end up with a negative on top, a positive for this first factor, and a negative for the second, which gets me to a positive infinity. And then I don't know if you guys can see this, but I have a graph there that justifies my answer. Okay, please, for me, make sure that you fill in the lesson summary that is Google form that is right below this video.